So, good morning everyone. My name is Mark Angelo Moncada from BSCS31, and in this video, I'm going to discuss the introduction for syntax-directed translation. Syntax-directed translation, or SDT, refers to the translation of languages using context-free grammars. SDT fundamentally works by adding actions to the productions in a context-free grammar. These are the concepts related to SDT. Attributes. An attribute is any quantity associated with a programming construct. An attribute can be any variable name, it can be the data type of the variable, or it can be the data stored in the variable. Examples of attributes are data types of expressions and the number of instructions in the generated code. Next is syntax-directed translation schemes. A translation scheme is a notation for attaching program fragments to the production of a grammar. The program fragments are executed when a production is used during syntax analysis. Syntax-directed translation schemes include several types of schemes such as postfix SDTs and SDTs with actions inside productions, which will be discussed deeper by the succeeding reporters. So the next is postfix notation. The police notation is the prefix notation, while the reverse police notation is the postfix notation. The postfix notation for an expression E can be defined inductively as follows. Number 1. If E is a variable or constant, then the postfix notation for E is E itself. Number 2. If E is an expression of the form E1 OP E2, where OP is any binary operator, then the postfix notation for E is E1 E2 OP, where E1 and E2 are the postfix notations for E1 and E2 respectively. Number 3. If E is parenthesized expression of the form E sub 1, then the postfix notation for E is the same as the postfix notation for E1. In the number 2, the operator was placed at the end of E1 and E2 obviously. So, here are the examples. Number 1, 9 plus 5 will be 9, 5, and the addition operator. And the next item is 4 plus 3 minus 1 would be 4, 3 plus minus 1, then 4, 3 plus 1 minus. It's because the operators was placed at the end. So compilers use the postfix notation instead of the infix notation, since in postfix notation there is no need to use parentheses to show which operations need to be prioritized or to be performed first. So next is synthesized attributes. An attribute is said to be synthesized if its value at a parse tree node n is determined from attribute values at the children of n and n at n itself. So, for example, here in the given tree, the green node's value is determined by the attribute values of the red nodes, which are the children of the green node. So next is simple syntax-directed definition. A syntax-directed definition associates number 1 with each grammar symbol a set of attributes, and number 2 with each production a set of semantic rules for computing the values of the attributes associated with the symbols appearing in the production. So here is figure 2.10, syntax-directed definition for infix to postfix translation. More of these will be discussed by the succeeding groups along with the construction of syntax trees. So next is tree traversals. Tree traversals will be used for describing attribute evaluation and for specifying the execution of code fragments in a translation scheme. A traversal of tree starts at the root and visits each node of the tree in some order, as you can see here in the given diagram. So we have depth first traversal. A depth first traversal starts at the root and recursively visits the children of each node in any order, not necessarily from left to right. It is called depth first because it visits an unvisited child of a node whenever it can, so it visits node as far away from the roots, as deep, as quickly as it can. So we have pre-order and post-order traversals, which are two important special cases of depth first traversals. in which we visit the children of each node from left to right. During pre-order traversals, the movement will be from the parent node to the left child node, then to the right child node. While during post-order traversal, the movement will be from the left child node, then to the right child node, back to the parent node. So, here are the references for this video presentation. Thank you for listening.